7.5, we're looking at simplifying radicals. So some of this is going to be review because we did a couple of review days on how to get radicals simplified. So we're going to go over a couple rules. This is the first one. So if you have a root where you have multiple things underneath it, you can break it apart, or vice versa. If you have multiple roots, you can put them together under one root. So here, two examples that we're looking at. Now both of these are examples of having roots separated, but by combining them it would actually benefit us. So looking at this example, now 8 is the same thing as 2 times 2 times 2. We're always going to look at prime factors when we're looking at square roots, cube roots, fourth roots, because we're looking for groups of numbers that match. Same thing with 27, that's 3 times 3 times 3. So if we put these together, we really have 2 times 2 times 2 times 2. Now, when there isn't a number outside of the root, what number is really there? 2 square roots. So you're looking for groups of 2 that match. Okay, so we've got a group here and a group here, so we can take those out, and then there's nothing left over underneath the root. So we take both 2's out, multiply them, and we get 4. So the reason I'm writing out the prime factors is because it will help us later when we have more complicated numbers. This next one, it's a fourth root. So we're looking for groups of 4. Do we have a group of 4? So we take that out and we get 3. Nothing left underneath the root. So let's add some letters into this. Copy these 2 down. So I'm not going to do the prime factorization of the A's and the B's, but I am going to rewrite this. So we're looking for groups of 4 things that match. So we do have a group of 4 with our numbers, so we can take that out of the root. Now let's look at our letters. The question is, how many groups of 4 are there that we can take out? So how many groups of 4 are right here?
6.
Okay, so we have a to the 6th power. And how many groups of 4 are right here? There are 3 groups of 4, but there's some left over on that one, right? How many b's are left? Okay, so there's 1 b left underneath here, but don't forget to put that 4th root on the outside. So that is the simplified version of that radical. Okay, next one, 32. Prime factorization is 2 5 times. X to the 8th. We're looking for groups of 2 because there isn't a number here, so we assume that we're looking for groups of 2. And anytime we find a group of 2, we can take that out. So we can take out a 2 and a 2. And how many groups of 2 are here? Anything left? Yep, this 2 right here. Now be very careful in how you write this. Even this probably isn't the best penmanship. Notice how this 4 right here kind of looks like it's on the 4th root. Really make sure that you have a space in between here, so this would be a better way to write this. So that I know that the 4 is an exponent and not on the root. So keep your eye out for that too. Questions on the first page? Yes. No, you don't have to, but I won't mark it wrong if you put a little 2 there. We good on this page? I'm going to give you about a minute to try these ones on your own, and we'll see if we can get the same answer in about 60 seconds. Just a little self-quiz here to see if you understand this portion of it. Did I make any mistakes, or did we match? Any questions on this piece of it? A couple months ago we did review this portion of it. Now we're going to get into more of the new stuff. We good to move on? Okay, here's the new stuff. Now, what's written up there for that formula isn't much different from the very first one that I showed you that was orange on the first page, where if you have a root that's over multiple things, you can break them up into separate roots. So that's the idea here. But here's the key right here. We can't ever have a radical in the denominator. Okay, we're going to have to get rid of that. And I'll show you how. So here's our example. I'm going to go step by step so that we fully understand this. And then we'll try a more difficult one on the next page. All right, so based on what's written up above at the very top, we can split this up into separate roots. And these are square roots, so we're looking for groups of 2. So let's simplify it, just like we have been doing. Nothing different yet. This would really be So that's what we were just looking at, just simplifying radicals. Now we can't have a square root in the denominator, and we actually talked about this last year in geometry when we were talking about 45, 45, 90 and 30, 60, 90 triangles. There would be situations where we would have to divide by a root if it was missing on a triangle. Do you vaguely remember this? Okay. How would we get rid of this radical on these problems? Do you remember? We would do something to the top and the bottom. We're not going to square it. Yes, we would multiply it by whatever root that was. Because essentially, on the bottom here, we would get 3 times 3, and on the top, we get 8 root 3. So on the bottom, it's really what? We just get 3. So now we don't have a square root in the denominator anymore. So we're going to use that same idea on this problem. What are we going to multiply the top and the bottom by? Yeah, we're just going to multiply by root y. Because now, underneath the root here, so nothing's going to change up here. Underneath the root, we now have a pair of y's, which is what we're looking for in a square root. We want that group of 2. So what is this right here? It's just y. So on the bottom, what would we write for our answer? We now have y to the 4th power on the bottom because we have this y to the 3rd times y. So let's check to see if we got that right. Yep. Any questions on any of those steps? We're going to try another one. All right. Let's look at this one. The 4th root of the fraction 6 over 5x. So let's just separate them first. We've got the 4th root of 6, 4th root of 5x. There's nothing we can simplify like we could on the previous problem. Okay, so we're at the point already where we need to get rid of this radical in the denominator. Now we're looking for groups of size what? Yes, groups of 4 things matching. So right now on the bottom, all we have is a 5 and an x. So how many more 5s do we need? 3 more 5s. And how many more x's? 3 more x's. So we're not just going to multiply by the 4th root of 5x. We wouldn't have enough to make a group of 4 things so that we could take that out of the radical. So we need to multiply the top and the bottom by 3 more 5s and 3 more x's. Let's do that up here too. So on the bottom, we're going to keep this as prime factors. Oops, we need 4s here. Sorry, guys. Yep, the top is 6 from the original problem up there. We're trying to just get rid of the radical in the bottom, so we're not even paying attention to the 6 right now. We're just trying to get rid of this root down here. So on the bottom, we now have 4 5s and x to the 4th. Okay, on the top, if we put those together, is there anything we're going to be able to take out of the root? Are there any groups of 4 anywhere? On the top. The 6 is a 2 and a 3, and then we've got 3 5s. So there aren't any groups of 4 that we can take out here. So let's actually multiply the 5 times 5 times 5 times 6, which I believe is 750. So nothing up there can be simplified at all. That just stays there. And it's okay to have a root in the numerator. On the bottom, though, we can simplify this. What is this simplified? Yeah, it's just 5x, which is awesome because we don't have a root anymore. And on the top, we just leave it. We got it right. Should we do one more? Okay, I'll make one up. Let's do the cube root of 2x over 9y. I'm going to do the same steps. So we're going to split them apart. Is there anything we can simplify, top or bottom? Groups of 3? Nope, we have a group of 2. So let's at least, instead of writing 9, it's really 3 times 3. So on the bottom, to get rid of that root, we need groups of 3, correct? So how many more 3s do we need? And how many more y's do we need? 2. So we're going to be multiplying by the cube root of 3y squared, which we copy up here. So now we have on the top cube root of 6xy squared. Just putting all those together. We can't take any groups of 3 out of that anywhere, so we can't simplify it. Now on the bottom, cube root of 3y cubed, which is groups of 3, which is what we wanted. That's why we multiplied by that right there. All right, so the top we can't do anything. 6xy squared. And on the bottom we have 3y. So you're always focusing on the denominator. How can I get rid of this root? I need to get group of whatever your number is on your root, group of 5, group of 7. In this case, we had to get groups of 3. We got 3 3s and we have 3 y's. Questions on that at all? All right, let's try a couple more things to talk about. Get this problem written down. Question? 6 is out in front, and so is the 4, yes. It's not on the root. It's just a big 6 on the beginning of it. Now the idea here that we're talking about is anything outside of the root gets put together and anything under the root gets put together and stays under the root. So what number is going to be out front when we multiply these? Put the 6 and the 4 together. Okay, we got 24. Now underneath the root, we're going to combine everything that's under the root. But let's write it in prime factors since we're going to want to simplify. So 8 is what? All right, so under here we've got 2, 2, 2, and 2. How many C's do we have? How many C's do we have when we put them together? There's 4 of them now. There's 3 from over here and 1 over here. And how many D's? We now have 8. So when we're done with this problem, are we going to have a root? Or can we take absolutely everything out? Yes, there won't be any leftovers at all. So we've got a group of 2 here and a group of 2 here. So we need to take those out. What are we going to do with those 2's and the 24? We multiply them. So that would be 96. And how many groups of 2 are right here? And how many groups of 2 right here? Let's see if we're right. Good. Kind of looks like me. Questions? Okay. Different idea. We're not multiplying these here, we are adding them. Okay, now you can't add roots together unless they're the same root. Think of it like a variable, combining like terms. So what we want to do anytime we see a root is to simplify it if we can, and we can on these. So let's get the prime factors of these roots. We got 2, 2, 2 for 8. And 50 is what? 2, 5, 5. So we're looking for groups of 2. Here's 1. Here's 1. So this is really what? Take that 2 out and multiply it by the 4. Left with 2 underneath there. we've got a group of 2 5s, so we take the 5 out. We now have 15 root 2. Now, remember what I said. Think of this as a variable, this root 2. So if we had 8x plus 15x, we would have 23x. So what's the answer in this case? Yep. Questions? We only have one slide left. Good so far? Write this one down. What are we going to need to do here? Let me make this problem simpler. What if we had this? What would we have to do? Not distribute. That's if we just had one number on the outside. We have to window or FOIL, whichever you're more comfortable with. Okay? I'm going to do window. That's what I'm comfortable with. But you can do FOIL in your notes. Ends up being the same. All right, so we put these along the outside. So this goes back to the idea that when you're multiplying radicals, the things on the outside, the numbers on the outside get multiplied together, and the things under the root get multiplied together. So if we're looking at 2 root 5 times 6 root 3, our answer is, what about 4 root 2 and 6 root 3? Here? Okay, so we just talked about what we looked at on the last slide on the left-hand side, multiplying the things on the outside together, under the root together. Now we're talking about the combining like terms piece in the same problem. Do we have any like terms right now? Okay, then the next question is, are there any of those roots that we could break down or simplify? What are our prime factors here? 3 and 5. What about here? 2 and 3. And here it's already to the smallest possible. So do we have anything we can break down? Any groups of 2? No. So nothing can be simplified, nothing can be put together. So then all 4 of these numbers have to stay separate, and they can go in any order you want. But you always need to check, can I simplify or can I combine any like terms? Because more than likely in the homework, they will give you one that you actually do. So look for that. Always simplify the roots if you can. Questions? We have one left. Now remember, we can't have radicals in the denominator. But this is a different situation because there's addition or subtraction in the denominator itself. Okay, so what we need to do in this situation, we wouldn't multiply by root 5 because we would still end up with a root in the denominator. So we're going to multiply by what's called the conjugate, which is just the opposite sign in between the two terms. So if we multiply these, we're going to end up getting rid of the root, and I'll show you that in a minute. But we have to also multiply the top by that same value, the conjugate. So on the top, we'll get to that in a second. Let's do the bottom. What do we have to do there? Same thing. Okay, FOIL it. Okay, root 5 times root 5 is right here. Here. And here. Now, when we do this, typically these two are like terms, and we do have like terms right here. What happens? They're gone. Okay, so we really have nothing right there. So our answer, which always lands on the diagonal here when we have something with like terms, we get what? 4. 5 plus 0 plus -1 is 4. So 4 goes where? Yeah, we just found the new denominator that doesn't have a radical in it. So 4 goes here. What's the top? Making sure that you distribute that 2 all the way through. Now for this chapter, I'm going to consider this a beautiful 100% answer. But it actually can look a little bit better by doing what? Okay, we could simplify by dividing everything by 2. But I want to show you an example that can't be. I want you to tell me why. Why can't we simplify that? What's the major difference? Right, we have 3 separate numbers here. All of your numbers need to be divisible by that same number. So I'm not going to expect you to get from this point to this point. We actually have an entire chapter coming up in chapter 9 where we're talking about how to simplify those fractions and rational expressions. So if you want to keep it here, that's great. If you do that, you may earn a sticker or some team points or something. But just don't get cancel happy and see this 2 and this 4 and go, oh, I can make that a 1 and make this a 2. Because this is no. Can't do that. Questions? Yes?
With the 2 square root of 5 plus 1, can you add together the 2 and the 1?
Good question. 2 square root of 5 plus 1 aren't like terms because they don't both have a root 5. So we can't combine those if we had that for an answer. Anything else that you want clarified?